Hi everyone, today in Integrated Math 2, we're going to go over Chapter 10, Lesson 6. Here are the objectives. Make sure you write them down in your notes. Alright, so the first thing that we're going to go over is Law of Sines. So for example, if triangle ABC has lengths A, B, and C, which represent the lengths of the sides opposite the angles with measures A, B, and C. If that is true, then sine of A is divided by A, which is equal to sine of B divided by B. Sine of C divided by C. They're all equal to each other. But here's a key part. It says representing the length of the sides opposite the angles. So you're only going to want to use the law of sines if we actually have sides opposite the angles. Alright, so let's try this example here. First of all, I have a degree, and the side opposite in this case is x, but let's check over here. 46, we have a degree, and we have an angle. Therefore, we can use the law of sines. So, we have sine of b divided by little b, which is equal to sine of a divided by little a. The reason I'm using a and b is because that's the information I have. I don't have anything for angle C or the side opposite of angle C. So that's why I'm using B and A. So sine B is going to be sine of 46 degrees divided by B. Well, that's going to be 13. This is the side opposite of it. Then we have sine of A, which is sine of 27 degrees. 27 divided by side of A, which is x. So we don't know what that is. Alright, so here we're going to do the cross product. Remember that looks like the x. You're going to multiply across from each other. So here we have 13 sine of 27, which is also equal to x times the sine of 46. So you want to get x by itself. That is the goal. I'm going to box it up. There's imaginary multiplication here. So I need to divide both sides by sine of 46. Alright, and that becomes 1. So that means x is going to equal just about, and then you put in your calculator. In this case, you're going to get 8.2. So x is right around 8.2 for the side length. Alright, now let's try another example. So first, we see that we have an angle, the side opposite that angle. We have that as well. So we can use the law of sines. So sine A divided by little a is equal to, and we're going to use b again, sine B of little b. Alright, so sine of A is 71 degrees. So sine 71 divided by A, which is going to be 25, which is equal to sine of x, because we don't know what b is yet, and then little b is going to be 13. Alright, so we want to get sine of x by itself. Ultimately, we want to find out what x is. But let's box this. There's division here. I want to undo that, so I need to multiply both sides by 13. So when you put this in the calculator, you're going to get that it's 0.4917, which is equal to sine of x. However, remember you only want to find x, so remember what we want to do is to find the inverse of sine x, because that does it. That goes away. If I do it to one side, I must do it to the other side. So x will equal right around, and you're going to put this in your calculator, and you're going to get that it's right around 29.45 degrees. Next, we have the law of cosines. If triangle ABC has lengths AB and C representing the lengths of the sides opposite the angles with measures AB and C, then we have A squared, which is equal to B squared plus C squared minus 2BC times cosine A. Or we have B squared is equal to A squared plus C squared minus 2 times A times C times cosine B. Or C squared is equal to A squared plus B squared minus 2AB times cosine C. All depends on what we're trying to find. One way that we can remember these, the first 3 letters for these ones looks very familiar, or it should. Remember the Pythagorean Theorem, that A squared plus B squared is equal to C squared. Well, that's what this part reminds me of. Then everything's going to be minus 2. It's always going to be the same 2 that you add are going to be multiplied times 2. And the only letter that you haven't used, in this case for A, is going to be cosine of A that you're going to multiply it to. And it's the same pattern for each of these. Alright, so if you see, first thing that we want to do is to check to see if we have an angle and the side opposite of it. In this case, we don't know what x is, and we don't know these other angles. So, good so far. If we did, then we should use the law of sines. It's much easier. But in this case, we're going to go ahead and use the law of cosines. Alright, so here I see at 43 degrees, and it's next to A. So I'm going to use the formula A squared, because I know what A is. Well, I have the information for this one. So A squared plus B squared plus C squared minus 2 times B times C times the cosine of A. Now I'm going to plug in my information. So remember, when it's little letters, it's going to be the side lengths. So this is x squared, which is equal to b squared, which is going to be 10 squared, plus c squared, which is 13 squared, minus 2 times 10 times 13 times cosine of 43. Alright, and then we put this in the calculator. And we're going to find that x squared is equal to 78.84. But I want to find out what x is. I'm going to square root both sides. That goes away. X is going to equal right around 8.88. Alright, now let's try another one, which is a little different. Alright, so I have a missing degree and I have a side length. So we know we're dealing with the c squared one. So c squared is equal to a squared plus b squared minus 2ac times cosine of c. Alright, so c squared, in this case, it's 10 squared, which is equal to a squared, 17 squared, plus 25 squared, minus 2 times a, which is 17, times 25, times cosine of c, which in our case is x. So then we have 100 is equal to, and let's chunk this up right here, and that is 914 minus, we multiply these numbers separately, 850 cosine of x. Alright, so those are paired up, so those like in a box together, which means we can move this one. Opposite of 914 is negative 914. So we have negative 814, which is equal to negative 850 cosine of x. Alright, so with that we can divide both sides by negative 850, because that's opposite multiplication. That becomes 1. Then we get, we'll put this in the calculator, 0.9576, which is equal to cosine of x. But remember, you're trying to find x, so this is where you want the cosine inverse. Once again, cancels. And if you do it to one side, you must do it to the other side. Then you put this in your calculator, and then you're going to get 16.7 degrees right around there, which is equal to x, and that is in degrees. And there we go.